Okay.
All right, excellent. Hi, Eric, how are you?
I'm good, Real. How are you?
I'm doing well here. I was just back from a week's vacation in Puerto Vallarta. So
Oh yeah, you're doing really well.
yeah. No, I had nice people bring me drinks on the beach, so it worked out.
Yeah.
All right, team, let's go ahead and you can start, and I will ask questions as I need to, and we'll get this done. Okay, over to you.
Okay. We will do a presentation before showing the
Okay.
rocket, so you can see the general layout and technical also.
Okay.
I will share the screen. Oh. You can see the presentation, right?
Yes.
Yep, I can see it fine.
Okay.
Hello, I am Ali. I am team leader of TOBB rocket, our second year in this competition. Our rocket is consists of three parts. These are nose cone, upper airframe, and lower airframe. Our rocket length is 2,675 millimeter, and our diameter is 133 millimeter. Our stability is 1.66 calibrator. Our apogee is 3,148 millimeter.
In this year, we will use the Aerotech M1850W. You can see the data from the thrust curve and the graphic from the thrust curve. Also, I think you are familiar with this.
Nice motor.
Yeah.
Yeah, and have you definitely got your motor set up to get once you get to the United States?
What? Can you repeat it again? Repeat
Sure.
question.
I know you can't buy that motor from Turkey, and you're going to get it in the United States. Do you have that all set up and firmed up?
We didn't purchase motor yet, but we will do it on Monday because we are waiting money from our school to purchase it. And
But it's
also
available, right? Somebody has it on hand, so you can just walk up to them and buy it, and then you'll have it.
Actually, we will purchase from US to a launch address, and then we will get it from the launch area. Then we will do the
we will get it in
assembly.
the actual conference area.
Yeah, conference.
In the last process. Last year
We did this last year.
yeah, there's no problem in this.
Okay. So the person you're going to buy it from has it in stock and on hand.
Yeah.
Okay.
Yeah. Yes, they have it. There's no problem with the motor purchase. They have it. It isn't sold out, thankfully.
Okay, press on.
Okay. We will use tangent ogive nose cone, and its fineness ratio is 4:1. And you can see the other dimensions in the slides. We will explain how we will explain to you later in this meeting. We are going to show you actually the nose cone, and we will explain it on. We will explain on it. Sorry.
Okay.
All right.
Okay. Yeah, we can go.
Here you can see the fin geometries. We will use four fins in this rocket. We will use aluminum plates with thickness of 5 millimeters. And in next slides, we will show you the assembly system of the fins. And here you can see other dimensions. And we use boat tail in this rocket again. We use conical boat tail and with angle of 14. Here you can see the fin and fin slots. This is a simple geometry.
Okay, what are you making your boat tail out of?
Aluminum,
Aluminum? Okay,
6061.
For our airframes, we use fiberglass for material, and we're planning to manufacture coupler and bottom airframe with together, and its dimensions are here. You can see,
all right.
and our motor assemble and fin assemble. We're planning to our motor with upper engine bulkhead with 3.816 U and C, and also we assemble our upper bulkhead with upper body with 3 metric 5 bolt and 1 metric 4 bolt. 4 metric 4 bolt, metric 5 bolt. And for our lower bulkhead, we use 3 metric 5 bolt and 1 metric 4 bolt. And also we use 2 centering ring for assemble. As you can see right there, we use 4 fins, and also we connect them with our boat tail, and also our motor with and our motor and our bulkhead connects in bottom, as you can see.
Okay.
And also these are our dimensions, centerings, and our upper and lower bulkheads.
Right.
And the avionic mechanic system, we just have one upper avionic bulkhead and one lower avionic bulkhead. And there is 3 metric 5 bolts on the upper avionic and 1 metric 4 for the rail buttons. And there is 1 metric 8 eye bolts we use in the upper bulkhead, and 2 black powder capsule on there. And the other avionic system is shown in the left side. And the payload system. Payload system has 2 bulkheads, which is made from the steel, and the 1 cover for the steels, which is made from the ABC, manufactured from the 3D printing, and the whole assembly is shown in the right side. And our payloads make the using the dampers, we just try to make the flight vibrations minimize, and we just make the analysis for this. When we looking at the analysis, we just make the analysis with damper and without damper. We just minimize the all displacement with using the damper, and we just try to get all the data from the avionics system on the payload.
Okay, so go back to your payload slide just a second.
Okay.
So this the 3D printed cover, that's not really a structural piece. It's just covering up, right? Is that the
Yeah.
as I understand it, the way I understand it from the way your thing is diagrammed?
Yeah, it just assembled from the outside of the you can see from there outside of the bulkhead, and the getting assembled with the bolts using in there.
We use 3D cover for actually
Part explosions.
yeah.
What material are you using for your
Cover.
3D printing there?
PLA.
PLA. Okay. Yeah.
Okay.
Okay. Press on.
Thank you. Now I want to present your recovery subsystem. In our rocket, we will use black powder separation, and 2 separation will occur in the flight. First one is nose cone and upper airframe, and the second one is lower and upper airframe. We have total of 4 bird capsules, black powder capsules in our recovery subsystem, and 2 of them will be backup for the separations. Now, as you can see in the screen, all of the recovery subsystem components. On the middle side, first separation, the second separation, CAD drawings, and the right side shock parts On the bottom of the page, you can clearly see on the left side the payload parachute, and the middle side drag parachute, on the right side main parachute.
Okay. How big is your main parachute?
250 centimeters diameter, and I can also say the other parachute sizes.
Okay, go ahead.
The drag parachute have 90 centimeter diameter, and the payload parachute have 150 centimeter diameter.
Okay.
What's your
Um,
main parachute descent rate? Hello?
8.8, something like that.
8.8 meter per second probably.
Okay.
So, okay, so about just under 25 feet per second when you hit the ground.
Can you repeat it again?
So I'm doing the math in my head. So you're right around 24 or 25 feet per second when you hit the ground.
I don't know feet per second.
Actually, we can
We can look from the open bucket.
We are looking the open rocket.
it is good. This is still
28?
28.7
28.8.
Yes, 28.8, like your estimation.
per second.
Okay.
Okay.
You say something before that it should be before or above of 25 feet per second. Can you repeat it again? 25.
Okay, I'm just looking at I've got a converter up on my phone right now. What's your descent rate under main again in meters per second?
We can say feet per second. Feet per second.
If it's okay for you, we can say it feet per second. The meter per second is approximately 8.72, but we can see right now the feet per second. We changed the units. Which one do you want actually? Feet per second or meter per second?
Per second.
Right.
Okay.
Now.
Okay, got it. All right.
Okay.
What's your shock cord made out of, and how long is it?
Yes, probably polyester. Yes.
Meters.
We have two shock cords, and one of them is 5.5 and meters, and the other one is 2 meters.
Just
Ooh.
just 2 meters for your drogue there? Is that the one you're talking about?
Yes, hello. Yes.
I think yes, it is.
Okay, yeah, you're gonna need to relook that because with that short of a one, you get a problem with when you deploy with that short of a shock cord, you know, it's not gonna have any time to slow down, so you're gonna really you really increase the chances of something happening there. And then plus with only 2 meters, your nose cone and your body are gonna just knock against each other.
On
you know,
descent.
Yeah, on descent.
Yeah, I think both of them are short.
Yes, I'd agree. Yeah, so you need to relook that. You know, normally, how long is your rocket again?
Uzunluğuna kaldı.
Length is,
2000,
yeah,
2006 millimeter.
267. Yeah, so you're probably gonna need to be looking something closer to about three, somewhere closer to eight or 9 meters of shot cord for both sides there. And then fasten the parachute about 1/3 of the length between that, because otherwise, yeah, both of those shot cords are too short.
Okay. Okay,
So
we
you
will.
need to go back and recalculate those,
Okay.
and then once you do, please send me a note so I can update my information.
Yeah, it's much better to have them too long than too short for sure. So if you're thinking on the edge, you can even go even longer. If the cord fits in there, then you'll be okay. But definitely go longer, because you're going to have a lot more problems than if you're short, or if you're short than if you're long.
Yep, absolutely. Okay,
Okay.
and what are you using to fasten it? Do you have like quick links or what?
We will use quick links and swivel links. We will show you later if you.
Okay, I'll just wait on that.
And I'm sorry, I don't think they, what's the shock cord made out of again?
Polyester.
The material of the shock cord?
Polyester.
Polyester.
Uh-huh.
Polyester.
Polyester?
Yeah.
Okay,
And,
okay.
Yeah.
Also, we will use the cover for the polyester shock.
You got a Nomex heat shield? Okay, over there, okay.
Yeah, good. That's a good idea with that kind of shock cord. Yeah. All right.
Okay, let's continue with avionics, I think.
Okay,
So-
press on.
So we are going to use two cords and one SRAD systems. As you can see in the diagram, we are using a main avionics control flight unit as a altimetrum telemega, and we are using RRC3 sports altimeter as a backup system. And we are using our SR system as a payload avionics, just for communication and telemetry data. So these are the altimetrum telemega, as you can see on the photographs, and this is the RRC sports altimeter. We are using 9-volt alkaline battery because of the LiPo batteries are not safe and they are not recommended by the manufacturer of this RRC3.
Right.
Using telemegas LiPo batteries. The manufacturer of the telemega recommends the LiPo batteries. This is
Okay.
our SRAD system. As you can see on the photograph, there's a BME 680 environmental sensor. We are using this for pressure, humidity, and temperature. And this is our microcontroller for this SRAD system, Arduino Mega. So this is the gyro for our system BNO 055. These are the micro SD modules for telemetry data savings, and this is the eBud E32 for the LoRa communication.
Okay, what are you using to power that?
We are using LiPo battery again, 9.4 volts, 900 milliamperes to power that.
Okay, so So this is your shred thing. You need you can't use a lipo battery there. You need to use
Alkaline
Equine or a lithium ion or something
Yeah.
different than that. I mean, you got plenty of choices out there, but the only way we're letting folks use lipo batteries is like in the case of an Altus Metrum, where that's what the manufacturer recommends. Since
Yeah.
you built that, then you need to avoid using a lipo battery.
Okay, we thought that we used it in our Technofest competition in Turkey, and there is not a problem with that. So we thought that lipo batteries could be using in this competition, but if you say so, we could always change it to other batteries.
Yeah, no, it's very clearly stated in the last revision of the rules and requirements and in the DTAG that lipo is a no-go unless it's like an Altus Metrum where it's required by manufacturer.
Okay. So we are going to use this teledongle as our ground station, and this SRAD receiver as a ground station as well. This is only for payload, and this is for the main avionics.
Okay.
This is the live video challenge.
Yeah, we are participating in the live video challenge. So we designed the receiver and transmitter system. So this is a basically transmitting system for the live video. We have FPV cameras, and so there's a transmitter with 1.3 gigahertz. So in the ground, we received it, and we are using the input for the live video out.
Okay, and I'm looking at your transmitter that looks like a 3.7 lipo battery.
Yeah, we
Yeah,
will.
okay.
It's not
Need to get rid of them all.
Yeah, we are
for show. We're
just for working.
we're just testing the system.
Okay.
Okay.
Okay.
We are going to change the proper way.
Okay, very good.
That's
for
all for
our
us.
presentation.
So maybe we can look the table, so we can show the
We would
parts.
like to show you our rocket and avionics systems. Yeah, recovery system as well.
Okay, yeah, show us your rocket.
So we are changing our forms. Now, can you see the phone camera?
Yes. Oh, there we go, much better.
Okay. I will shut the voice down in here so we can speak in that phone, so there's no voice.
Okay.
Okay.
Tekrar söyle.
Can you hear us?
Yeah, you get kind of an echo there, but
It should be fixed. It's fine.
Okay, now can you hear us?
yes, much
Better?
better. Thank you.
Okay. Where should we start?
Let's start from Moscow.
Okay. You can see our nose cone geometry and the shoulder.
Shoulder.
All right.
We will We will use
Okay.
glue, and then we will again use fiberglass and lay one layer. And this
Okay.
is we use 3D printed general geometry of the nose cone with thickness of 1 millimeter. Then we laid one layer outside of the geometry. Then we laid 6 layers inside of it. We did same for the shoulder.
All right.
And we will glue them and from here we will glue them and this in tip of the nose cone we will use aluminum, which is still manufacturing.
Yeah.
We couldn't finish the metals manufacturing because we had a problem with CNC.
There's a problem with the CNCs and backup part are just coming from the out of the steels. So we're just waiting for the CNC. There was a little bit problem on there.
We are waiting for approximately 1.5 months for our metal parts, but travel.
Is that
Fine.
okay for you?
Okay, so how soon do you think you're going to get that your aluminum tip sorted out? What's your time frame for getting that?
We will get it next week.
Next week.
Yeah.
Okay.
They're starting yesterday, and they said that it's gonna be ready for the next week.
Okay. Okay. And how are you just going to epoxy your coupler into the bottom of the nose cone? Is that what you're doing, or are you using screws to hold it together?
No, epoxy and hand layout.
Okay.
Okay.
On the
Okay.
table, yeah, we can start from there. Payload parachute, fiberglass heat protector, drag parachute, swivels, shock cord, carabinas, main parachute, and shock cord protector.
Okay. Those carabiners, you're going to have to. Are they positive locking there, and what is the strength?
Strength of the shock cords.
Yes.
No, strength of the carabiners.
Actually, it is very high.
It just made it from
It is steel.
Cast iron.
Cast iron.
Cast iron. It's, actually, they are made from cast iron.
And its strength is
Very
very
high.
high. I don't remember the
Exact
exact
number of
number, but it is very high.
Also,
I can easily say.
we used them in the last year, so we trust them.
Okay. Okay, and that's. Wait, can you hold one of those closer to the camera just so I can see how they? Okay, gotcha. So it's just does that the collar there, does that twist on, or is it just slide on?
It is like that.
It's with screw
There
and
is
the cover.
a screw.
Okay.
You can look like that.
Oh, yeah.
Okay, I see it. Okay. All right.
Black powder capsules. Also, you can see the black powder capsules.
They're assembly.
Yes. Bulkheads.
Okay, have you tested the system and have you ground tested the system and the charge sizes?
Yes,
We did prototype test, and if you want,
we can show it.
We can show videos.
we can show videos.
Okay, but yeah, you don't have to show me the video, but you did have an actual successful test then.
Yes, yeah, a lot of tests.
Okay,
How many
Okay.
grams of black powder are you using in the upper and lower?
3.5.
Yes. Yeah.
3.5 grams.
For each one?
Yeah.
Yes.
3 and 3.5.
That's the upper and lower.
Yeah. For first separation, we will use 3 grams, 3 and 3.5 grams. In second separation, we will use 3 grams.
Okay.
okay, yeah, you know, you've got a good ground test and because yeah, give me the diameter of the airframe. Just tell me in centimeters, will you? Is that about
In
100?
centimeters, in a
Yeah, about-
meter is
125 millimeter.
millimeter.
For bottom.
For lower.
So about 100 millimeters. Is that your
100
airframe diameter?
130 in upper inner diameter of the airframe.
Okay. Okay, so a little bit more than 4 inches.
Yeah.
Okay.
Okay.
Also,
Okay,
we can-
and did you make those yourself? The airframe sections?
Yeah, we can. If you want, we can show you that now.
Okay, go. Yeah. So you did you hand lay your fiberglass to make your airframe, or did you buy it from somebody?
We buy.
We buy it from somebody.
We purchased it.
Is there a problem or?
No. I'm just asking. Are these commercially purchased airframes, or
Yeah.
did
Yeah,
you
no.
lay them
Actually-
yourselves?
Actually, they are not commercial airframes. We use just for us for the dimensions, but we didn't manufacture it. We buy it from another manufacturer.
Okay, got it.
Also, we can show you that with the coupler section.
Okay,
Okay.
and are you using
Shear pins.
shear pins? Yeah.
Yeah, we can use.
Also, we can show you the shear pins also.
Okay,
And
I can see it.
upper.
So you're using 4 shear pins, both
Yeah,
for
4 shear
your
pins.
upper and lower.
Yes, we use it for shear pins.
Okay,
Actually, they are connected. One shear pins enter here and the axial here. So in both upper and lower, we use 4 shear pins.
okay,
Also, in last year, actually, it's a prototype, the thin geometry, thin assembly geometry. We are waiting for the metal parts, but we use aluminum pins. So this is just a prototype.
okay. When do you expect to get your final parts here?
In this
Again,
week, yeah.
next week.
Yeah, again, next week, actually. They will manufacture them in next week. So actually, we talked that before all metal parts, all aluminum parts will be manufactured in the next week.
In this week.
Actually, it's, in this week, in the next Friday,
Yeah.
they will come, can take them from the manufacturer.
Okay. How about your rail buttons? What are you using for your rail buttons, and how are you how and where are you fastening them?
Just 1 second.
It will be upper avionics and lower avionics. Okay.
Before their location, we have 2 pair of the rail button. That's the metal ones we use in the Technofest in Turkey, and these ones we buy them last year from the animal rocket, the animal motor in the
Okay.
area.
Right, yeah, and you plan to use the black ones, right?
Yeah.
Okay, yeah. All right, and how are you fastening them? And show me where you're fastening them on your airframe and how you're gonna do it, how you're holding them on.
Okay.
Okay, so, yeah. So where does that tie in? Do you have a centering ring or a bulkhead that they're tying in or something
Yeah.
behind there?
We got upper avionic. Upper avionic
avionics.
bulkhead and lower bulkhead.
Lower motor bulkhead.
Motor bulkhead.
Okay, so you got them in your bulkhead. How far apart are they?
Uh,
It will be like that. Other will be
That's that
150 millimeter.
160 millimeters.
it will be here like that.
Not
Other
600.
will be here, correct?
The lowest part. Yeah,
Here.
yeah, in here.
It will be something like that. This.
Okay,
Yeah.
1,600 millimeter approximately.
Yes.
okay.
Yeah.
Go ahead, Eric.
I just think that's a little, it'll still work, but I think it's a little far apart.
Yeah, that was gonna be my comment too. What is your exit? What is your velocity when that top rail button clears the rail?
They are checking it right now.
We can change the length.
Also, we can change the length.
The other rail button can be here. If we say it's too long.
Yeah, because here's what the potential issue is that, tend to get fairly decent winds out at the spaceport, and then soon as that top rail button clears the rail, then that rocket is going to be free to pivot about the bottom rail button, and you need to make sure that you've got enough velocity at that point to keep it flying straight, so it doesn't weathercock over on you. So that's why I'm asking, what is your velocity, rail exit velocity when that top button clears?
31.6 millimeter per second. Meter per second.
Meter per second.
31.
Say that again.
31.4 meter per second.
31.4 meters per second.
Velocity
So
of
just,
roll.
okay. And what's your stability margin at that point?
They're also checking.
1.66.
Well, yeah, so 1.66 caliber at that point,
Yeah.
and that's your minimum stability margin.
Yeah.
Okay. Yeah, you might want to consider, moving that top button a little bit, closer to the bottom button, just to give yourself a little bit more margin.
Can you repeat it again?
So you may want to consider moving your top rail button closer to the bottom rail button to give yourselves a little bit more margin.
Okay.
Okay.
Is that a
We will
4 foot
do it.
section? The bottom booster part? That one tube is 4 feet?
Can you repeat it again?
So the bottom tube, just one tube, how long is one tube?
How long is the 100? 1,100. 1100
Just give me in meters.
meters. Meter. 1.1 meter.
Okay. Yeah, you might even put the top rail button on that same tube. Put the bottom and top on the rail button on the same tube
No.
if possible.
Ay, niye arkaya koydunuz diye farklı koydum. I didn't understand. Can you repeat it again?
Put both rail buttons on the same tube on the booster
No,
section.
no. Different tube. On the different tube. Our rail buttons.
You are suggesting put the real buttons in the one tube like that, right?
Uh-huh.
Yeah, there we go.
Yes, that's much better. It's much better.
Yeah, we
Yeah,
can
we
change
can
it.
change it. We use that system with upper avionic bulkhead last year. It's approximately here, and there was no problem. So we want to use it in that way again, but we can change the.
This is much more.
No
big.
problem.
This
Yes,
is
it's much
big.
more. Yeah, actually, this is easier too.
Yeah, it'll probably still work. We're just recommending for the wind shear that we get out here.
Yeah, you're right.
But that right there is how most rockets that we see fly in the US are set up, about that close.
Okay.
Okay.
Let's
Okay.
continue
And
with avionics. Let's
yeah.
continue with the avionics.
Okay.
As you see before, these are the main SRAD systems around. These are the microcontroller of the system. This is the the sensor of the temperature, humidity, and pressure. This is the gyro of our system for the X, Y, and Z coordinates. And this is the GPS of our system. This is only for the payloads, for the recovery. And
Okay.
these are the, as you can see, these are the backup sensors, and this is the ceramic antenna for this GPS. And these are the main avionics. This is the telemega, as you can see. It's on right now. Yeah, it is working just fine. We were just testing a couple hours ago. So this is the backup system for the RRT3. As you can see, there is alkaline peel. We were just testing this. Let me on. As you can see, it works just well as well. And these are the
Video components. You can see this is still working, and we can see the monitor that we are gonna output. So let's walk to the computer. Here is the directly output. So you can see telemetry data from the telemega.
Okay. So I guess at this point, I'm a little bit more interested in how you plan to mount all that in your avionics bay. How do you
we will use avionics plate similar like this. We will
Okay.
use we will just mount this like this, similar like this. This is the old one. We changed and revised it, and this is the communication module. As you can see, it's hanging out. It's because we would like to.
Şuradan delik atıp arkaya
Yeah, we will just
cut the plate and
cut the blade and do something, do screwing and tighten this up.
back side
For,
of the.
yeah, backside of the avionics plate.
This is just for payload.
Yeah, this is just for payload.
So the RRC3 and Telemega is in the same plates for
Similar
the
like
main
this,
avionics,
yeah.
similar like this. And there is a cable, so you can see
Okay,
there is some connectors. This is like that. So easily you can connect the. Assume that there is a igniter,
right.
so you can trigger that easily. The upper side of the bulkhead,
Okay.
and there is a powder, you know.
Okay. Do
We
you-
will use ties for this batteries and this battery. Not this one actually. This is a lipo battery, as we told. We will use zip ties and silicones for the batteries for not the removing and make it tight so it doesn't remove or drop anything on the avionics system.
Okay, do you have a design, a picture of the design of how all your parts are going to be laid out in your avionics bay? Or are you kind of cutting and fitting it as you go?
Yeah.
Bakayım mı?
Bence burayı göstereyim. Kamerayla göstereyim.
Yok, direkt kamerayla gösteririz.
Just wait for 4 seconds.
Okay. Tamam.
Gözüküyor mu? Gözüküyor.
Evet.
Şeyi kapatsana. Ekran paylaşımı. İşte yaklaş işte.
Yusuf linke girsen daha kolay olabilir sanki. Can you see
Can
it
you
clearly?
see it, or we can just share the video if you wait?
Yeah, I think I can see it. So you've got your RRC3 mounted laying flat in on the kind of on that middle bulkhead there. Yeah. Okay.
There's a plate.
Right. And then
There's a plate.
and then your other stuff is going to be mounted flat on your internal or horizontally on your internal bulkheads there.
It's gonna be vertical like this. This is for the main avionics. We will use RRC3 right there, as you can see, and we will use the Telemega, similar to what we showed you just 5 minutes ago. We will use vertically for this Telemega. This is the part where Telemega goes.
Okay.
So we would like to show you a payload too.
Okay.
Payload
Go ahead.
avionics. Just 1 second.
İstersen bağla.
Tamam, benim telefonum.
Okay.
So this is the payload avionics, as you can see. These are these are this is the main microcontroller for our this system. This is the temperature, pressure, and humidity sensor. As you can see, this is the gyro sensor what we talked about,
Okay.
and this is for just the GPS. This is the antenna for this GPS. This is the GPS U-Blocks Neo 8M, and this is the e-byte communication module. This was just a prototype. This is the circular one, but we are going to use the rectangular one in our system.
Okay.
That's it.
Right. And where are you going to mount your batteries?
We will mount our batteries. Yeah, we will mount our batteries like this. We will use, like as I said, silicones and zip ties to tighten them up.
Also, you can see
Okay.
the ionic battery.
Right. Yeah.
Yeah.
Yeah. So those the gray boxes are essentially where your batteries are going to go.
Yeah.
The
Okay.
battery
Is that a
going-
battery right there on the bottom?
yeah.
Yeah.
This one, just 1 second. Look,
Is that a 9-volt?
this one was the battery. Oh, I will
Yeah.
look at it. Yes, this is 9 volt, right?
Yeah. This is the 9 volts. This
All
is
right.
the
And you're going to need zip ties to hold those, right?
yeah. We will use zip ties. We drill the plates and we will zip tie them on the surface, as you can see.
Not the
So make sure you use good quality zip ties.
What?
Yeah. Yeah.
I'm sorry. Can
Yeah.
you repeat?
I mean, you need to make sure you use good quality zip ties or to have some other way of making sure that that battery stays where it's supposed to under your planned acceleration and vibration.
Yes, you are absolutely right. We will make sure of it. We will use quite quality zip ties and we will use some silicone to glue them on the surface, and we will use zip ties to tighten them up.
Right. You know, because the other thing you could do is, you know, make a kind of a bracket for it that, you know, kind of wraps around the battery so that you've got, you know, positive, so that battery's not going to go anywhere. And then you can just add a zip tie lengthwise to keep it, you know, sliding from one direction to the other. I mean, that would be another, you know, I mean, there's a lot of ways to go about doing that.
Yeah.
But you know, that's one thing that you know we're gonna look at pretty closely once you get to the convention center.
Okay.
Okay, we cover the plastic or something.
Yeah, we will manufacture the plastic cover and we will do it like you say. We can change our strategy for assembly.
We will note it.
Okay. And what kind of switches are you planning to use?
The K ones, not the buttons or
K switch.
yeah.
We will use K switch to open. Can show it to you. Sorry. We will.
We have used.
We don't have it. We don't have it right now, but we will use K switch to open the systems in the avionics systems.
So are you using not quite a, there we go.
This is similar to like this, yeah.
Okay. So you'll have three different ones, one for your payload and two for your regular arming.
Yeah.
Okay,
Yeah, exactly.
okay, good. So can you show me your fin can again, and you know, just explain to me how your motor, how that's going to mate with the with your aft body tube, and how the motor's going to fit into that.
We can show from the presentation.
Zeus.
Okay, okay,
Can you hear me?
yeah, yeah,
We can fix with our upper motor bracket.
right.
Right there with 3816 UNC right there.
Okay, good. Let me, yeah, show me the that looks good. Show me the other end again, where near the tail. Okay. And
Also in like that with our boat tail.
The motor fitting on the boat tail.
okay,
there.
So we
yeah,
can
so
make
your boat tail kind of slides in around your fin can, and then you screw that on, attach that with screws.
Like that.
Ah, okay.
The boat tail just keep the motor steady
Okay,
on the side.
right, right. So your boat tail is essentially your aft engine retainer.
Yeah.
Okay. Okay, so that's good. Eric, do you want to see any more of this part right here?
Oh, no, looks good to me. He's actually
Yeah,
got two.
yeah, it looks very nice. Yeah, it's a nice design. I'd feel better if I saw it finished, but it's the design looks very, very, very solid. Okay. Just a question that came up as you were talking about your payload. Since you're deploying that payload, at what altitude are you planning to deploy your payload?
500.
No. We will deploy our
Apogee.
On Apogee.
we will
At
deploy our
Apogee?
Yeah,
Yeah.
on the Apogee.
In the first separation.
Okay, so so you're gonna put your drogue out first and then put your payload out, or the other way around?
We will first deploy the.
I think it's
payload.
same time.
First, we will deploy the drag parachute, then the payload will be deployed.
And then the payload goes inside the
Okay.
Right.
Yeah, and so you're doing both of those at apogee, and you're doing your drogue at apogee, and then your payload with, you know, what, 1 second delay, 2 seconds?
The deployment will be at the same time in the same apogee.
Okay,
So what pulls the payload out?
Uh,
Pressure of the
At
black
the-
powder.
So you have
Pressure of the
the
powder.
separation.
we will
Okay, so
separate
the powder will push the payload out and that pushes the
Yeah.
nose cone off.
Yeah.
Okay.
And we have already
is
tested.
that what's happening? Okay, okay, got it. Okay, I'm just trying to picture that in my head. All right.
Actually, also Yusuf, our friend can show you the chat. Okay, can you see it? Okay.
Yep,
Okay. The ignition happens in the lower part of the actually near part
Right.
of the payload. So the pressure with the ignition, the payload goes along with the parachutes and the nose cone out, and the payload and the parachutes out and the payload out. Basically means
okay. And so the payload, which is the part that's in the reddish color, is gonna separate with its own parachute.
yeah.
And then your drogue is actually that, the light blue right up in your nose cone. Am I seeing that right?
Yeah, that was the drug part.
Okay.
That was the payload parachute and the payload.
Okay. And so where are you routing? You're routing your shock cord. Is the payload, is your payload gonna be, it's on its own parachute, so it's descending separately from the rocket, right?
Yeah.
Okay, and how are you routing, since your payload's between the your attachment point and your drogue, how are you routing your shock cords here?
The one okay.
one side will be here with this.
Right,
Okay,
Here.
yeah.
And other side of the shock cord will be here, and
Yeah.
just put them through the nose cone.
okay,
Right.
so, yeah, so Eric, help me out here. I guess I'm having trouble understanding how they're gonna
It looks like
make
they're
sure it
running the
doesn't
shock
get
cord.
tangled up in their shock cord when they eject their payload.
Right. Yeah, and it looks like they're running their shock cord on the side of the payload
Yeah.
section between that little bitty space.
Yeah.
Yeah.
Payload
Payload
goes,
will can you show the cross section of the payload?
just 1 second.
There.
You can see the payload aids are cut. So
Oh, I
Ah,
see.
oh,
Okay.
okay, all right, good. Yeah, so the shock cord is gonna go along those that flat section there.
yeah.
And then the payload will slide out next to that and do that. Okay. Okay, got it.
So the only thing I'm kind of worried about, Bill, is the explosions pushing the payload up and then
Yep.
kind of compressing all the shock cord there and making it a big tangled mess.
Right, yeah, I mean, I guess that's yeah. I mean, and I can see why that forced them into a shorter shock cord, but that's what they have is too short. So they need to figure out a way to for want of a better word, gracefully be able to do that, unless you have like all the shock cord toward the aft end of that with just enough to reach the front to attach onto the chute. That might work. But looks like there needs to be, room on one side or the other of the payload section for all that, for sufficient enough length, 10 meters of shock cord.
Yes. Okay, and you're putting the bulk of
Yeah.
your shock cord for your nose cone closest to the nose cone, right?
Yeah.
Like the big wad of shock cord, all the excess is going to get wadded up and it's close to the nose cone.
Yes.
Yeah.
So that's your excess shock cord is going to sit in that area.
Yes.
Yeah, in this area.
Okay. Yeah,
Okay.
I think that's the best place for it.
Yeah. Yeah, but do you see where we're coming with this? That you've got your payload section with the shock cord running next to it, and we want to make sure that that thing, either the shock cord doesn't get all tangled up, which would cause you quite a bit of problems, or that payload's going to be able to separate cleanly without getting tangled up with your drogue. Because that's, you've got, both of those potential situations, the way you've got it set up.
This is the reason why we want to deploy the payload first. We didn't want them to be tangled with the drogue parachute.
Payload will not go inside the nose cone, so it's efficiently separate the nose cone and the body. So we are not thinking they can share the nose cone.
Okay.
Okay, and how long is your shock cord for your payload section?
We will not use shock cords in payload.
They will
Okay,
direct.
that's good. Yeah,
payload.
it'll be fine that way, and that'll be probably better.
Yeah. Yeah, so that your payload parachute's gonna just attach right to the payload. And
Yeah.
Yes.
And
Okay.
and the attachment will
Okay.
type of.
Okay, got it. Okay, for your
No, go on. You just
Yeah.
ask me.
So I got a couple questions I want to clean up here. So for your fins, have you done flutter calculate? What's your max speed, and how does the fin flutter look for that?
It was.
It was in the report also. Just
Do you
clarify.
remember the exact number?
The exact number is 1,000 and something like that. And our
1,000.
max speed is the 268.
1,000 meter per second is our flutter speed, and our speed, our maximum speed will be 2,000.
68, I think.
286 meter per
Okay.
second.
Okay, so plenty of margin there. Okay, good.
Also, we wrote the basic calculation code
In the
to
technical
show it in the technical report. You can see in the appendix.
All right. Okay, Eric, do you have any questions or comments you'd like to make beyond what we've already
No,
talked about?
I think we covered everything. I'm good. Just those, definitely the shock cord. Definitely
Yes.
increase the shock cord. Look at moving those launch lugs back. And everything else looks good.
Yeah, and just
Oh, the battery
like I said,
retention,
yeah,
especially
the
in line
batteries
there.
just, yeah, make sure that you know, the only thing you can use a LiPo for is your telemega. So, you know, whether you go with lithium ion or you go with alkaline batteries, whatever, that's up to you. But you need to make sure you fix that part. Okay. So you've got your motor well in hand, which is good. How are you planning to get your rocket to the United States?
Yeah, actually, that's the funny part. We will transport it with as our baggages.
Okay.
Last year, we packaged them in Turkey, and we use as a second baggage from Turkey to USA, and we transport them like that.
Okay. So you're going to transport your piece parts and your baggage.
Yeah.
Okay. Let's see. And do you got a place where are you staying in Las Cruces then? Do you have
Yeah,
a
we are
hotel,
staying
Airbnb, or what?
in the Airbnb.
Okay. And do you have you arranged transportation both
Yes.
from the airport and then also while you're at the competition to get you back and forth?
Yeah, we arranged the transportation. We will use the Ford Ford F100, Ford F150
Okay.
for the transportation.
Okay. So how many of you have been out to the spaceport before for the competition?
5
Anybody?
of us. Yes. 5. Me,
Okay.
Özge, Ali, Çat, Yusuf, Matt, and
Okay.
Yusuf. Okay.
Okay, so you make sure you brief your friends, your teammates about the weather. It is extremely hot here. It's, as a matter of fact, today, and I live just south of the spaceport. It's just about 100 degrees Fahrenheit today. And we can expect that hot or worse during the competition. So make sure you dress accordingly. If you'll see me, I'll have a big floppy hat on. I'll have a shirt that long sleeve, thin long sleeve shirt to keep the sun off of me. I'll be wearing long pants and good shoes because it's not super dangerous. It's not particularly dangerous out there, but we do have nasty critters. Snakes and pretty much any kind of bug you see is going to try to sting you. And all the plants, every plant there has something sharp to poke you with. So just make sure that you keep that in mind when you're out here. This year we will be providing tents, so shelters and tables for everybody. So you just have to make sure that you have chairs. Otherwise, it'll be an uncomfortable sit on the ground. So you have to bring your own chairs, and we will have, of course, the food vendors. We will have a water buffalo where you can get water, but the water out of the tank in the truck is not the greatest water. So I'd plan on bringing my own water in coolers, so you can have good drinks, sunglasses, sunscreen, and so forth. Okay, how's your visa pictures? Has everybody gotten their visas yet?
Yeah.
All of them.
Also, 6 of us have our flights purchased.
Okay,
Yeah, our flight.
okay. All right, good. So you've got all that stuff going. Do you have, is everybody who's coming, or especially those of you who are going to be working downrange or working on the rocket, have your AAA memberships?
Yeah, we all have.
For the students or whatever. Okay, and if you haven't voted in the AAA elections, I encourage you to do so. Let's see. Does somebody have? Okay, so you're using LoRa for communications, right? For your telemetry, or are you using or ham? Are you be working on the ham band, the 2-meter bands for your for your telemetry and for your GPS?
Yeah, we are using LoRa for our GPS and communication and telemetry data. Yes, I didn't get
Okay. And does somebody have a ham radio license?
Yeah.
They both
Okay.
have license.
Okay. Okay, good. So let me just a couple things. When you get to the United States with all your rocket pieces, you know, do not paint your rocket in your hotel room or do all your epoxying or anything else. We've had some teams who chose to ignore that guidance and ended up with great big bills from their hotels to clean all that stuff up afterwards. So, you know, make sure that, you know, if you haven't got the pieces painted already, that you find somewhere else to do any painting or gluing that you need to do.
Okay.
Yeah.
On that note, I live in Las Cruces, and I have a pretty nice shop behind my house. I live near the
Oh.
university, which is
Oh,
in
do you?
the
Okay.
convention center. So if you guys need any workspace or anything, let me know. You can come over and use my shop.
Okay.
Outstanding, Eric. Very, very, very good of you. Yeah.
And do
Yeah,
you have
I
a
did-
supplier for black powder when you get here? Black powder?
Actually, we need to purchase in US because we can't
Transport.
them from here.
Right.
Act-
Have you found anybody, or do you know any? Do you have some you can buy some from, or do you need a connection?
Actually, we need a connection. Last year, Steve give us the black powder. Steve Taylor. But this
Okay.
year-
I'll bring some 4F as a backup for you, so that you've got that in case you can't find anywhere else.
Okay, yeah. And the last time I bought black powder locally was Doniana Mountain Ammo. Damn Ammo usually has
damn.
it. Yeah,
They sell 4F there?
yeah, 4F, but the minimum is a pound. So it would be
Okay.
probably a lot more than they would want.
Well, that's right. I mean, I can use black powder
Yeah.
for many things.
Sure, yeah. Yeah. Okay. Are you planning, so you're planning to take all your stuff with you? Are you planning to ship anything else to the United States? Or are you gonna carry everything yourself?
You're going to
Yeah.
carry
Yeah,
everything. Everything.
Okay. Okay, good. Just as a reminder, when you're driving back and forth between Las Cruces and the spaceport, there is a Customs and Border Protection checkpoint that you're gonna have to go through. You know, just make sure everybody's got your proper ID and everything else. You know, we've been briefing the Border Patrol guys, so they know that the teams will be coming. Should not be any kind of issue, but you know, just in case, just make sure you keep all your appropriate documentation on you. Okay.
You will take our passwords with us.
Okay, good. All right. Do you have any questions for me?
Bu video yükleme olayınızla ilgili soru sorabiliriz. Yok. We will upload this video to YouTube, and then what should we do, or what is the process?
Yeah, if you send the shareable link to info@ezrarocket.org,
Okay.
I'll email you the address to email it so that you have it.
We have to do it before the 1 p.m. in here or before the
No,
deadline?
you can just do it soon as you're ready.
Okay.
You know, us talking this is the official event, so we won't, don't worry about making the exact time as far as that goes, because people knew my travel issues, so so that's not a problem.
Okay, thank you.
Okay, anything else for me?
Can we take a photo for our social media?
Can we what now?
Can we take a screenshot for our
Social
Instagram?
media.
Oh yeah, of course.
Okay.
3, 2, 1.
Cheese. Dur.
Second.
Just one second.
Windows Shift S.
Oh, okay. 3, 2, 1. Say cheese. Okay, thank you. Okay, thank you.
Seni oynattım.
Evet.
Düştük.
Um,
Burada
Burada devam ediyor.